I've been talking about this LAN as if it's one wire that is acting as a link to connecting everything in the same LAN. But in fact, there may be switches inside of this LAN to get frames from this machine to this router, say. So these switches have a job very similar to routers in that they have multiple ports coming in and out, and a frame coming in on one port needs to be sent out over an appropriate other port to get to its destination machine. Now, in the case of a frame like this one that's a broadcast, that switch's job is easy. It just sends the same frame out over all the other ports. But let's suppose that a frame comes in with a particular destination address. It could be broadcast out over all the other ports, but again, to lower the traffic on the ports that don't need it, we would like the link to send it out to the right port. So how does this switch know which way to send this frame? This is very similar to the question of routers and configuring where they send things based on IP address. But instead of replicating that whole set of machinery and protocols like OSPF and BGP to configure routers, at the link layer, switches are going to automatically infer their routing. It works like this. Say your switch is sitting here and a frame comes through that's broadcast, but it's coming from MAC A4CF and so on. The switch will send that broadcast out over all the other ports, but it also has learned some information meanwhile. Since this frame came over link 1 here, the switch has learned that MAC A4CF99 is on link 1, and if it ever needs to reach that MAC, it should send frames back out that direction. Meanwhile, since it's a broadcast, this switch is going to send it out over all of its links. Over one of these links, there will be some machine that wants to reply to this broadcast. When it replies, it can reply to that specific MAC, and the switch here knows which link to send out that frame to get to that MAC because it remembered that from before. At the same time, it has learned that MAC address 386077, so on, is on link 4 there. So it remembers that, and that way, if these two machines keep talking using MAC addresses that they've now discovered, the switch will also know those MAC addresses. So a switch is able to automatically configure itself because for different devices to know each other's MAC address, they will have discovered each other through the broadcast protocols, and the switch can watch that broadcast protocol itself. What happens if you have machines that are already talking and someone turns the switch off and then back on? In that case, for a while, the switch will not know which way to send frames, and so the network won't work right. It'll take a little bit of time for things to recover, and just in case that kind of recovery is needed, that explains why you're seeing these extra ARP frames in that Wireshark trace I showed you. Often there's just a lot of extra redundant declarations and requests to keep the LAN and its switches happy in case something has gone wrong at the switch level meanwhile. There's an older piece of technology called a hub, which I don't have a good icon for, so I'll just draw a switch upside down. A hub just broadcasts everything, so even if a frame comes in with a specific destination MAC address, the hub doesn't try to know where things are and it just broadcasting. So hub is more like a fancy wire that still connects all these machines and doesn't reduce traffic. Basically, there's no reason to use hubs anymore because hardware and software has gotten so cheap, you might as well make a switch that lowers traffic while connecting these different machines. So it's a historical thing. It's pretty hard to buy a hub these days because switches are so cheap, but it's something you might hear about. And if for some reason you have a choice, well, do choose a switch.